Okay, everyone, I think I'm recording. We'll see. This is a Quadratics intro blast. I'm going to do my best to cover a unit's worth of content in 15 minutes. Highly recommend pause the video when I introduce the problems, try and solve them yourself, then watch my solution. We're going to cover the definition of a quadratic function, graphing quadratic functions, solving quadratic equations by graphing, factoring, and the quadratic formula. And then there's a fun bonus modeling with quadratic functions problem to end things. Step one is for me to have a page ready to go. Here we go. So definition of quadratic function. We're going to define it by how one of the ways you can write it, a quadratic function. It's a function with an equation that can be written with the rule that the definition can be written in the form, the function definition, f of x. This is Howie, everyone.
Where do you live? I'm so sorry.
No worries. F of x equals x squared plus bx plus c, where a, b, and c are real numbers, and a is not 0. What happens if a is 0? Pause, think about it. You get a linear function. There he goes. See you, Howie. Have a great day. And when we graph a quadratic function, we get, no surprise here, hopefully, a parabola. Don't even really need to throw axes up, but I just, to make it comfortable, I'll throw them up. Here we go, parabola. Not a bad freehand parabola. It's got the properties of being symmetric, about the axis of symmetry. It's got an important point, the vertex, which is on that axis of symmetry. It may or may not have roots, zeros, right? These are the list of words that are all essentially synonyms, x-intercepts, and what we'll see in the next slide, solutions to a quadratic equation or the related function. So those are the x-intercepts, also called roots or zeros or solutions. Also might have a y-intercept. The y-intercept would be the value of c. I guess I didn't draw this, so it has a y-intercept, so let me slide that over. So we've got a y-intercept, that point right there, y-intercept, which is just going to be that value right there because x is 0, you're left with c. So y-intercept is the value c. There's a function for the axis symmetry, x equals negative b over 2a. We're going to derive that. a couple different ways in the unit. Um, if A is positive, then you've got uh, a, a minimum. A little neater. On the other hand, if A is negative, then it points down, frowns, however you want to say it, and has a maximum. Okay, so that's quadratic functions and their graphs. Uh, Now let's take a look at a few examples. Quadratic equation can be written in the form quadratic equation as opposed to a quadratic function. Quadratic equation can be written in this form right here. Usually isn't written in that form when you first encounter it. Problems ask us to solve quadratic equations. Several techniques to solve a quadratic equation. You can write the related function. That would be, so for instance, if we're solving this, we're going to take that problem and we're going to write it in this form so that you can see it's a quadratic equation. I'm going to move the 12 to the left, so we get x squared plus 2x minus 12 equals 0. Now it's in this form here. We could replace the 0 here with f of x, and we'd have what's called the related function, and we'd be looking on that related function for the points where y is equal to 0. In other words, the x-intercepts or the zeros of the function. And you could graph it and look for the x-intercepts, or you could factor the equation or use the quadratic formula. For this one, let's factor it. I don't want to get too distracted with factoring. In this case, when the leading coefficient here is equal to 1, it's called a monic quadratic, and you're just looking for factors of negative 12 that add up to 2. X plus 6, x minus 2. Whoa, this was a poorly planned problem. I did not plan this problem well enough. Let's leave it in. I don't want to lose Howie. So I meant to write 4x here, and for this to be a 4. Whoops. The product of the 6 and the negative 2 is negative 12. The sum of 6 and negative 2 is 4. So if I would FOIL or expand those two binomials, I would get that quadratic expression. So the solutions to this equation are the same as the solutions to this equation. I can use what's called the zero product property, where I have right here one term, let's call it A, times another term, let's call it B. A times B equals 0. Two numbers multiplied together equals 0. That tells you one of the numbers has to be 0. So I can think to myself, either x plus 6 is 0 or x minus 2 is 0, which means either x is negative 6 or x is 2. And those are the two values that would solve the quadratic equation. If I was to solve this quadratic equation here, similar process. Let's take and get ourselves another page of paper. Uh, move all the terms, jump all these terms over to the left, move them all to the left. So negative x squared combined with 2x squared, I've got 3x squared. The 3x, move it over to the left, 3x squared minus x. The 10 jump over to the left, minus 10 equals 0. Uh, Now I could try to factor this. In this case, the leading coefficient is not 1, so I can make a video and we can talk about techniques for factoring that, but just guess and check is often the fastest way to do this. I guess I wouldn't call it guess and check, call it kind of a informed intuition. We know that the product of that term and that term has to be 3x squared. If we're looking for integer, if we're factoring over the integers, we've got the choices of 3x and 1x, one way or the other. There is Howie's wife calling. Your wife is calling you. Here we go. I'm going to pause this. Let's see how this works. Uh, no, just once. Bye. Uh, so two numbers we know that the two numbers that go here have to multiply to give you negative 10. So could do minus 5 and plus 2. So I can think to myself, or minus 10 and plus 1. So I could just kind of try out those combinations. I could put a minus 10 here. Let me do it. I could put a minus 10 here and a plus 1 here. And then when I expand the 1 and the 3x and the negative 10 and the x, so I'm going to have a 3x and a minus 10x. That's not going to give me a minus x. So I could switch it around, plus 1 minus 10, but same problem. This minus 10 and the 3x is 30x and 1x. That's not going to give me a minus x either. So then we try the 5 and the 2, minus 5 and plus 2. That's going to give 6x and minus 5x. That's promising, but the signs are wrong, so let's switch them around, and I'm just going to write it in now. Uh, uh, Plus 5 minus 2. So now we have minus 2 times 3x, that's minus 6x. 5 times x, that's 5x. That does give us that term minus 5 minus x. So now I have that same situation where I have a number times another number equals 0. Zero product property again says 3x plus 5 equals 0, or x minus 2 equals 0. I can move the 5 over. 3x equals negative 5. X equals 2. X equals negative 5 thirds. I have my two solutions, 2 or negative 5 thirds. Quadratic formula, if I change this equation just a little bit, you'll notice that this equation is really similar to this one. If we just change that 10 to a 1, we can no longer factor it. So we'll use the quadratic formula on that. Here's our fourth problem. 3x squared minus x minus 1 equals 0. The quadratic formula tells me that the solutions to this quadratic equation are given by x equals negative b plus or minus square root of b squared minus 4ac over 2a. So I can plug in my a, b, and c values, right? Going back up to this right here. So right here, a is the coefficient x squared. It's called the quadratic coefficient. B is the linear coefficient, and c is the constant term. So I read those off. A is 3, B is negative 1, and C is negative 1. And I can plug in x equals negative, negative 1 plus or minus the square root of negative 1 squared minus 4 times 3 times -1, just plugging these values into this, over 2 times 3. Simplifying, x equals 1 plus or minus the square root of 1. -12 times -1 is +12 over 6. So I get 1 plus or minus the square root of 13 over 6. I should try and simplify the uh, square root of 13 here, but the square root of 13 doesn't have any perfect square factors, no factors other than 1. So I'm done with that problem as well. And the final bonus problem, uh, modeling with quadratics. This is a fun problem. Tour bus in Boston wants to maximize its income. Serves 400 customers a day. The charge is $5 per person. The owner of the bus service estimates that the company would lose 10 passengers a day for each 50-cent fare increase. Can we use this assumption to model the situation with mathematics? You know what? I think this is such a good problem. I want to do it with you all in class when we have class. So you're done if you've taken notes. Uh, we'll do this as a do now activity. And that's it. Have an excellent rest of your day. Good luck taking notes on this. And let me see if I can find the stop